ப்ளே பண்ணி பார்த்தேன். அப்புறம் கிளாரிட்டியாக தான் இருக்கு. பட் லைவா நம்ம இப்போ நீங்க லிசன் பண்றது கொஞ்சம் டிஃபிகல்ட்டா இருக்கும். மேபி நெட்வொர்க் ஸ்ட்ரீமிங் உங்களுக்கு சம்டைம்ஸ் கிளாரிட்டியே கிடைக்கும், சம்டைம்ஸ் நெட்வொர்க் கிளாரிட்டி கிடைக்காது. ஸோ நெட்வொர்க் ப்ராப்பரா இருக்காது. பட் நான் கிளாஸ் ரூம்ல இப்போ போஸ்ட் பண்றதுல யூ குட் ஹேவ் தட் 100% கிளாரிட்டியாக தான் ரெக்கார்ட் ஆகுது. ஸோ யூ குட் ஹேவ் தட் லேட்டர், ரைட்? ஸோ வெரி குட் ஆஃப்டர்நூன். So before entering into today's topic, we need to recall the previous class what we have discussed, right? So in transformer na, what is the major important parts, right? So in a DC motor na, DC motor or generator, what are the different parts which is involved in that constructions? The same way DC motor la pathomna rotor and stator and carbon brush and yoke outer body as well as slip ring, that's called my commutators, right? So these are the important parts in solo. The same way in transformer, what are the important parts? Anyone just list it out? What are the major parts which is involved in construction of a transformer? Anyone? Actually in motors la pathina we are having a number of moving parts, right? So we'll have moving parts here, but inga pathina there is no moving parts, everything is now fixed. So here I'm just giving AC power supply as an input. Now I'm just getting an output over here, that's called electrical load. I'm just going to connect. What are the major parts will be involved in transformer? So there is a this is what my magnetic core and this is my winding. So these are the major parts, right? One is magnetic core. These are the important parts, right? So winding. So winding la two windings irukku. Windings la two, primary as well as secondary. Primary, secondary. So these all they will have two types of windings, right? So primary and as well as secondary. So you'll step up, we are just having a cross step up transformer as well as step down transformer. So how we just identify step up and step down transformer based upon the number of windings, right? So if the number of windings in my second series is very high compared to my primary winding, this is called, obviously it's called a step up, and vice versa we call it a step down transformer. We have discussed, right? Now we'll have one more small thing, right? So this is called step up. I'm just going to draw it 1 second. So we need a small recall, right? That's why, right? So only two windings. My output side 1, 2, 3, 4, 5, 6. So this is called my step up transformer. If it is so, 1, 3, 4, 5, 6, and 2, 3. So these two examples for step up and step down. So input power supply and load. So input power supply and load, right? So here N1, here N2. So N1 is less than N2, that is N2 is now greater than. Here N1 is greater than to N2. So this is called step up transformer, this is called step down transformer. So by having number of turns difference, right? So the help of this one, right? So we'll have in my today classes we are just going to discuss one more type of transformer. It is quite interesting, right? And before entering into this topic, so we need to recall that the previous working principle, right? So working principle is nothing but it's a Faraday's law of electromagnetic induction. It's very easy. Whenever the current is flowing inside any closed path, right? So there is a magnetic flux line is going to be set up. So the induced flux lines will be how it will be look like this, right? So எப்படி இருக்கும்? So input voltage current and input, right? This is my input voltage if it is alternate in nature, right? So definitely if I induce a current, it will be in alternate in nature. Definitely the input current is also, it will follow the same pattern. If I induce a flux lines, it will be, then it will be in the same pattern. This is called alternating nature, right? So this is what we have discussed in previous classes, right? So this is what my input power AC, 230 voltage for example. So this is what my first cycle. So this called, this waveform indicates my voltage. So definitely the current is now going to flow because of we are just applying as a current, and current will follow the same pattern which is the voltage, and induced flux lines based upon electromagnetic induction principle. So flux lines is also Faraday's law, right? So I'm just going to, right? So if you just found in our last previous birth, நீங்க கண்டுபிடிச்சா உங்க பேர் வச்சிருக்கலாம், right? So no issues. and due to flow of current inside the cycle, definitely flux line is going to build it up. So on the flux lines oda structures pathina the current oda structure and the current oda structure இருக்கும், right? So now it's the alternative nature, right? So இதனால என்ன கிடைக்குன்னா, there is a self induced EMF is going to be built on my primary coil, as well as my second. The same principle is going to be applicable in my second side. So that's why self induced EMF is going to be built on our second side, that is what my induced voltage on my second side. So these are the thing we have discussed, right? So அப்ப நம்ம fairly speaking or maybe openly speaking, right, broadly speaking, so transformer in the sense in our mind, right? So there is a two things is going to be coming, right? So one is my மைண்டுக்குள்ள என்ன வரும், டிரான்ஸ்ஃபார்மர் மைண்ட்ல இருந்தாவே உங்களுக்கு டிரான்ஸ்ஃபார் மூவி நம்ம வந்தாலும் பிரச்சனை இல்லை. டிரான்ஸ்ஃபார் பார்ட் 1, 2, 3 பம்ப்ளி ரோபோட் அப்படி, ரைட்? ஸோ நோ நத்திங் ராங் இல்லை. ஸோ சேம் கான்செப்ட் தான் அந்த படத்துக்கு நேம் இப்படி வச்சிருக்காங்க, ரைட்? ஸோ டிரான்ஸ்ஃபார்மர் திடீர்னு கார் இஸ் நாட் கோயிங் டு கன்வெர்ட் இட் இன்டு legged robot, and again sometimes, right? So after fighting, that legged robot is now again converted into car. There is a now transformation is happening, right? So the same way here also, why on the film camp pair vachanga it could have this meaning, right? So here I'm just applying electrical energy. Electrical energy is now I'm just electrical energy is now I'm giving to this first finding. Now the energy is now converted into magnetic energy. Again secondary magnetic energy is converted into electrical energy. So car, legged robot, car, that's called transformer, right? So this one also, why that name has that meaning, right? Film, right? So அப்ப நம்ம மைண்ட்ல டிரான்ஸ்ஃபார்மர் என்ன மைண்ட்ல வரும்? ஸோ ஓகே, ஒரு கோர் இருக்கும், அது செல் டைப்பா இருக்கலாம் இல்லை கோர் டைப்பா இருக்கலாம். we have discussed that cell type and core type transformer. So transformer நம்ம மைண்டுக்கு அப்சல்யூட்லி என்ன வரும்னா, so there is a two windings is now wounded on one common core அப்படிங்கிறது மைண்ட் வரும். But it's exactly correct, no issues. But we'll have one more type of transformer. Let's see. So பாருங்க, this is a third type of transformer. It's a quite important topic as well as today. And this is a winding, right? I'm just going to apply as voltage, right? So if it is a single phase voltage, 230 50 hertz AC source I'm applying. So definitely we know whenever the current is flowing inside the circuit, right? So high current is now flowing. So now this is made up of copper coil. So definitely there is a flux lines is going to be built it up. So on the flux lines oda length எப்படி இருக்கும், அதோட structure எப்படினா இந்த மாதிரி இருக்கும். That's why we have discussed, right? So here I'm just going to make one small thing over here, right? So instead of for a transformer நம்ம already நம்ம சொல்லிருப்போம், we need a core, we need a two individual windings, right? So instead of using two individual winding, now I'm just using a single winding. So right, single winding எப்படி பண்ண பாருங்க. So in between I'm just make a physical direct electrical contact between two winding. So இங்க என்ன பண்ணோம், we'll have a common core, but common limbs la use பண்ணாம we'll have separate limb. So in the leg னு சொல்லலாம், limb னு சொல்லலாம், right? So I'm just wounded a two winding. This is called primary winding, this is called secondary winding. But இங்க என்ன பண்றேன், இந்த arrangementல I'm having a one core, அதில் நான் காப்பர் வைண்டிங் சுட்டிருக்கேன். பட் செகண்டரி, instead of using secondary winding, I'm just having a direct electrical contact. This is not insulation. So I'm just having a direct welding, right? So direct soldering or welding, the direct electrical contact, direct electrical contact, right, between this winding. So எடுத்துட்டேன், இங்க common point வெளியே எடுத்துட்டு வரேன். So here I'm just going to apply a load or a connected load, electrical load. So what is going to happen? So it's not a difficult, right? So you could see the same electromagnetic induction principle, self-induced EMF is going to build it up in this coil. But now I'm just having output this portion alone, because I'm just going to connect electrical load between this little portion. Now watch me 1, 2, 3, 4, 5, 6, 7. So totally N1 will be around 7 turns, right? So totally 7 turns. This is called my primary winding. This is called my primary winding. Total how many turns? 7 turns. So I'm just applying 230 voltage. Definitely now adiketha mari flux lines is going to be built it up, right? So but I'm just taking a portion of output from this entire winding. Eppadi eduthukkana 1, 2, 3, 4. So appo N2, that is called only 4 winding. And the 4 winding across that I'm just going to connect a load. Appo enna agum, partial amount of flux lines is going to be, right, developed over here, right? Partial amount of, ஏன்னா பார்த்தீங்கன்னா ஃபார் எக்ஸாம்பிள் நான் 7 டர்ன்ஸ் எடுத்ததுன்னா 230 வோல்டேஜ் ஃப்ளக்ஸ் லைன்ஸ் அப்படியே கவர் ஆகும். பட் ஐம் ஜஸ்ட் ஒன்லி டேக்கிங் அஸ் அவுட்புட் ஆஃப் பார்ஷியல் வைண்டிங்ஸ். அப்போ என்ன கிடைக்கும், எனக்கு ஐம் ஜஸ்ட் ஒன்லி ஏபிள் டு கெட் partial flux lines, right? So partial flux lines மட்டும் எனக்கு கிடைக்கும். So then I could able to get only partial output. So I could able to get only 115 voltages output, right? So you could have meaning, right? So one coil you could have as output, right? So it's the same coil is now act as a primary coil as a secondary coil. இங்க பாத்தீங்கன்னா primary, இங்க பாத்தீங்கன்னா secondary. So as a single coil can able to act as a primary winding as well as it can act as a on the same coil or some of portion is now act as a secondary coil. So single coil is now act as a both primary as well as secondary coil. So in the type of transformer is called as this type of transformer is called as auto transformer, right? So this type of thing is now called auto transformer. Auto in the sense in Greek words, right? So it's called self. So auto in the sense Greek they will call as self. Self in the sense mono, that's called one. That is called one winding. So self winding, right? Self-induced EMF here, self and auto. That's why it's called auto transformer, right? So today topic is now auto transformer. Concept is very easy. So normally in transformer ரெண்டு winding ஒரு core இருக்கும். But in auto transformer we'll have only one winding. The same winding is now act as a primary as well as secondary, right? So is it clear? Anyone just have a small snap? We'll move into detail, right? So we'll move into little detail. Just make it fast. Anyone? Make it fast. Yes, thank you. Right, we'll discuss in somewhat in detail. So why it's called auto transformer in the sense it's going to use only one winding. The same winding is now act as a primary as well as secondary. That's the answer, right? So I'm just going to draw neatly. 3, 4, 5, 6, 7, 8. So for example, I'm just taking 8 turns, single phase power supply. Step by step follow பண்ணீங்கன்னா உங்களுக்கு ஈஸியா அண்டர்ஸ்டாண்ட் ஆகும். So that's why I'm having சொல்றேன் 50 hertz AC power supply. Right, so now I'm having a center point, right? So I'm just having a center point. I'm just have a direct electrical contact. There is no paper insulation. There is no nothing. So direct electrical contact. It's very important. Direct electrical contact. And I'm just having a output over here. So இதுக்கு நடுவுல across I'm just going to connect a load. A lamp இருக்கலாம், fan இருக்கலாம், whatever may be electrical loads, right? So let's see, we'll discuss a little in detail. So this is my coil, right? So this is my entire coil. So A, B, and there is one more portion. So I'm just consider as C. So A, B, C. So total turns this side. So total turns. So this is what my primary side, because I'm just giving input over here. Here I'm just giving input. So that is why my primary side. So this is what my output. So this is my secondary side. Right, so this is what my primary side. So total n number of turns will be now connected throughout the power supply. Total n power supply is given to the entire circuit. This is called n1. For example, we are having 8 turns. For this example, 1, 2, 3, 4, 5, 6, 7, 8. Right, so my secondary side I'm just connecting load across this portion of this winding. So this is n2, because I'm just getting output from this portion alone. So n2 is now 1, 2, 3, 4, 5. I'm just going to take it as 5 turns as the output. So n1 is now 8, n2 8 is 5, and A to B is now primary side, B to C is my secondary side. So input voltage is going to be built up on this one V1, this is my E1 or V1, right? So இதுக்கு across இருக்கிறது input voltage E1 and sorry V1. Induced EMF is on this entire coil itself. Induced EMF is E1, right? So in the inducer in the coil in the portion of is now responsible for E2. So E2, right? So my input applied voltage is now V1. So entire circuit, right? So, but my self-induced EMF these coils, self-induced EMF is going to build it up due to d phi by dt, right? அதோட self EMF ஓட value E1, So but in a portion that occurrence, so N2 is now 5 turns. In the 5 turns, like the flux lines is now converted to for E2 or convert ஆகப்போகுது. That is why my self EM E2, right? So N1, N2, E1, E2, V1, and d phi by dt single phase power supply, right? So now the same transformer ratio will be applicable. So we already discussed, right? So transformer ratio another, so N1 by N2, V1 by V2 is equal to E1 by E2. That is the transformer ratio we have discussed. Now I'm just going to find out how many voltage is now built upon my, how much voltage is built upon my secondary side. So I need to find out E2, right? So for that purpose, I'm just going to rearrange it. So N1 by N2, E1 by E2. So I need to find out how much voltage is going to be set up on my secondary side. That's what my question. So now I'm just going to rearrange the equation. So E2 மட்டும் தான் எனக்கு unknown variable, I need to find out. So இப்போ என்ன ஆகும்? So E1 by N1, am I correct? E1 by N1 into N2. So this equation it will become like this, right? So now we'll have E1 voltage now 230, already known value 230. N1 is now 8, its N2 is now 5, right? So instead of 5, let us consider 4. It will be easy for mathematical purpose, right? So let us consider 4. It will be easy to have a calculation, right? That's why 4, right? So now 1 by 2. So 230 now is now converted into 115 voltage. So my secondary side voltages will be now 115, right? So secondary voltage is now 115. So how I just calculated based upon number of turns, right? So based upon number of turns, I could able to count that. So secondary voltage will be 115. So for example, I'm just giving 230 as my input voltage, 230 as my input voltage. As of this construction, I could able to have less than 230 voltage, right? So நல்லா வாட்ச் பண்ணா தெரியும். So 230க்கு எனக்கு இன்புட் கொடுத்திருக்கேன், but I'm only able to get 115 voltage. So இப்போ என்ன இருக்கு? Voltage is now stepped down actually. So this is called stepped down auto transformer, right? So stepped down there. அப்ப step up பண்ண முடியாதா sir? Definitely we couldn't able to do step up in this construction. So என்ன பண்ண முடியாது? We are only having output over this small portion from this entire coil. So that way we couldn't able to get 230 voltage மேல போகவே முடியாது, because only we are getting in the total winding 230 voltage கொடுத்தோம்னா 230 voltage output வரும். But where we are just connecting, we are just only able to getting this small portion of this entire winding. So they definitely could have that knowledge, right? So we wouldn't able to get more than 230 voltage. We are just only able to get less than 230 voltage. This is why it's called step down auto transformer. Okay sir, அப்ப step up க்கு என்ன sir பண்றது? We will have one more question, right? So anyone just have a small snap, we'll go with that step up auto transformer. How we are just going to convert this single arrangement into how we are just going to move into step up. So but in this case, definitely you will not get step up voltage, because we are getting a small portion. Got idea, right? So we are only getting a small, this number of portion only from this entire portion. So definitely we could have only less than 230 voltage, right? So this is why it's called a step down auto transformer. Anyone have a quick snap? We'll move into step up transformer, right? So it's not difficult, it's very easy actually. Yes, anyone? Thank you, Krishna, right? So now let's carefully see. I'm not going to change anything, right? So I'm not going to change anything at all. Let's just see. I'm just going to change only small things. Let's see. It's very easy, right? So I'm not going to change anything. The same winding, same number of turns, everything is same. Now I'm just going to interchange the input and output terminals. Let's see. I'm just only changing the input and output terminals alone, right? So load. I'm not done anything. So I'm not changing any tapping. I'm not changing any number of tones. Nothing I'm not changing, right? So only I'm just changed this input and output terminals, right? Now, single phase, 230 voltage, 50 hertz, AC power supply. AC power. Now N2 is now 4, N1 is now 8, so N2 is now 8. See, because I'm just giving input this side, now it will become N1. I'm just getting a load here. That's why it's called N2. So I'm not changing anything. Only notation I change, right? See, let's see now. Now I'm just going to give you the input power supply to this portion, right? I'm just going to give you the electrical power supply portion as B to C only. I'm just giving. Now about 4 winding only I'm just giving. But see, as an output I'm taking from entire coil. See, A to B entire portion is now taken as my output side. So this is what my output side. Here only I'm just giving input, right? So input. Let's see, input la pathina I'm just going to only giving this 4 number of winding only. I'm just going to connect to my input power supply, right? But let's see, in the coil pathina again there is a series connection, right? So na inga connect panna input na inga connect pannalum there is a case the coil is made up of series circuits. The coil is now not going to stop here. The coil is again continually winding on this entire portion. The winding is now entirely electrically connected. So அப்ப நீங்க இவ்வளவுதான் இங்க current கொடுத்தாலும், right? So the current is always also flowing in this extra setup of coil also, because there is a series connection of this coil. So N1 tones also seriously connected with my N2 tones also. So நீங்க எங்க current கொடுத்தாலும் the current is going to flow this entire coil. So அப்ப entire flux line is going to be built up. So அப்ப entire க்கு தான் என்ன பண்ண போறோம்? I'm just taking output, right? அப்ப we'll have one more small calculations over here. See, now for E2 side, I'm just going to calculate power on E2 side, voltage E2 side. Now it will be become E1 side. Now we'll have that same equation. So E1 230, but N1 is now 4, right? N2 is now 8. About 2 inga row, so total up 460 voltage. My secondary side now 460 voltage, right? Up you could have that meaning, right? So my input voltage 230, my output voltage is 460. So now we could clearly identify that the input voltage is doubled about 460. So it indicates that this is now stepped up actually, right? So this is now stepped up. It's not stepped down, it's now stepped up transformer. So as a single same construction, right? How we have discussed in DC generator. So DC generator is now act as a DC machine. DC machine act as a DC generator, right? So DC motor is now act as a DC generator, as well say the same setup is now act as a motor as well as generator by changing its input and output, right? So the same way in transformer, that is one single phase winding transformer, that is called single winding transformer. By changing its inputs and outputs, you could able to convert step up as well as step down. By interchanging its input and output terminal, you could able to act as a stepped up transformer, or maybe step down transformer, or maybe step up transformer by simply interfacing its input and output terminals, right? So this is the one point I'm just going to would like to say, right? So this is the last idea mind note பண்ணிக்கோங்க. By interchanging its input terminal as well as output terminal, by changing this, you could able to run the same setup into step up as well as step down. So any doubt in this? I'm just going to wind to over here. We'll move into one more area. So 3 phase ke the answer, right? So I'm just going to move into next one. Anyone just have a quick snap over here by simply interchanging its input and output terminal. Anyone just make a quick snap. எடுத்துட்டீங்களா? We'll move. Yes. This is what a auto transformer, right? So it's very easy. Now we'll have one more question, right? In industry, right? So definitely they will ask this question, right? So we already started about this transformer concept, right? So what is the role of transformer in transmission lines, right? So transformer is நம்ம நிறைய learn பண்ணிருக்கோம் why the transformer is needed and what is the principle and why it's working and what is important in power transmission, right? So it's going to step up and step down, power loss நம்ம reduce பண்ண முடியும். We have discussed many things, right? But in electrical power transmission, so electrical power transmission side, right? So we'll see, we'll have a real-time example. We have Mettur thermal power plant, coal-fired thermal plant around in Mettur. Now we are as a consumer here, generation station will be here, right? It's G, generation station. Now as a consumer, we are in somewhat Coimbatore, right? So we are in a country around 400 kilometers away. We are a customer, right? So we are in around 400 kilometers away from this generation station. How the electrical energy is now flowing through that conductor only. But without a transformer, we have discussed a lot, right? So many losses is going to happen. We need to build a much area of that conductor. We need to build it up. It's a very huge tough job. So for that purpose, what they have done, that they just introduced transformers, right? So they introduced transformers to step up and step down voltages, step up, step down voltage current, as well as, and then through this we could able to reduce n number of losses, power losses, right? So it's a very important role. This is why I have discussed. But we'll have one more question. AC power, we'll have generation station. So generation station, they're just going to generate two types of power. One is alternative power, one is a direct current power. So we'll have two types of electrical power. One is the alternative current, one is a direct current. So the entire topic we have discussed about the transformer is now in initial case we are just able to connect only single phase power supply or three phase power supply. So நம்ம இப்படி தான் டீச் பண்ணி learn பண்ணிருக்கிறோம். But we'll have two types of power, right? So AC as well as DC. So we are only discussed about AC power transmission with the help of transformer. So why not DC, sir? Why we are not able to transmit the DC power a longer distance, over a longer distance? ஏன் பண்ண முடியல? Right? So அப்ப DC power நம்ம transformerல கொடுத்துட்டு we could able to do that, right? So but we are not able to do that. So நம்ம ஏன் இந்த மாதிரி பார்க்கவே இல்லை? எங்கேயுமே மார்க்கெட்ல பார்த்தீங்கன்னா DC transformer ஒரு கான்செப்டே இருக்காது. Right? So actually அப்ப what happened to the DC power? Right? So அப்ப AC மட்டும் தான் transmit பண்ண முடியுமா over a long distance, right? So in while those olden days, right? So DC power தான் initially find பண்ணது, that's called Edison group. So in USA பார்த்தீங்கன்னா Edison தான் அவங்க ட்ரை பண்ணி போயிட்டு இருக்காங்க டெவலப்ல, right? But they couldn't able to what could I say? They couldn't able to transfer the power from around to maximum 200 kilometer அவங்களால travel பண்ண முடியல, right? Because of length increase R is now directly proportional to L by A. So length increase conductor distance is getting very high. So voltage drop ரொம்ப அதிகமா இருந்துச்சு. So power loss நிறைய இருந்துச்சு in DC sourceல, right? So அவங்களால travel பண்ண முடியல. So that's why many things that they have just faced in it. So while coming to Tesla, that's called alternative power supply Tesla, they just bring it with a new idea that's called transformer concept. You could able to travel around 1,000 2,000 kilometers, they will just go with it. So step up பண்ண முடியும், step down பண்ணிக்க முடியும், they will just do it. அதனால இது ஃபேமஸ் ஆச்சு AC power supply. That's why it's get famous, right? These are the big issue they have faced, right, in olden days. Okay, sir. But DC, there is one question. When you are just attending any core industry interview or technical interview in any core type of industries, so definitely 200% they will raise a question. They will raise a question like this, right? So AC power, DC power, right? So they will definitely 100% they will raise a question. So this is what a question. I'm just going to give it to you. So you people need to give an answer, right? So I need a couple of answers at least from your side. So I'm just, before into that raising question, I'm just going to write draw a circuit diagram. Right. So this is my primary side. These are my secondary side. Right. So these are my secondary side. So Google path nothing wrong in it. Just need to understood that concept actually. So load, right? So this is what my AC power supply. So no issues, we already discussed, right? So instead of, the question will be this one, right? So the question will be this one. So question is that, so if I'm just going to connect a DC source, I'm just going to connect a DC source to my transformer of primary winding, whether the power is now going to be delivered on my secondary side. Anyone just have answer? If I'm just going to apply a DC power to my primary side, whether the transformer is going to deliver as an electrical power into my secondary side, is what my question. Is it is it working actually? So this is what a question. If I'm just going to connect a DC power supply to my primary winding, connect panna, so whether you will able to get a power supply on my secondary side, or maybe the question will be like this. So if I'm just going to connect any DC power source in my transformer, what is going to happen in the next second? Within a second, next second, what is going to happen? So anyone? Google pin so I'm happy about that. No, nothing wrong in it. If I'm just going to connect a DC power supply to my primary side of any winding, what is going to happen? So last class I post பண்ணிட்ட batch 1 நம்ம video post பண்ணிருந்தேன். நீங்க பாத்தீங்கன்னா அந்த Google Classroom I'm just posted a video class video. So the same question I have asked to our batch 1, they give an answer, I think, right? So நீங்க பார்த்தீங்கன்னா தெரிஞ்சிருக்கும், right? Anyway, batch 2 students, anyone, if a DC power is given to my primary side of a transformer கொடுத்து என்ன நடக்கும்னு நினைக்கிறீங்க? Whether I could get output from my secondary side. ஏன்னா நம்ம ஏசியில் அப்படி தான் பார்த்தோம். ஏசியில் ஏசி சிங்கிள் ஃபேஸ் பவர் சப்ளை இங்கே கொடுத்தோம். டெஃபினட்டாக எனக்கு செல்ஃப் இண்டஸ்ட் இஎம்எஃப் கிரியேட் ஆச்சு. அப்புறம் they can change in flux lines with respect to happen in my secondary side. One more EMF is going to be generated and my secondary side will get output. Number of turns you could able to adjust and you could give a step up, step down when got it right. Now in DC source, what is going to happen? Anyone? I'm just going to wait around 1 minute at least. என்ன நடக்கும்னு நினைக்கிறீங்க? Anyone need to tell? Anyone? யாருனாலும் சொல்லலாம். நீங்க பேசினா போதும். யாரும் உங்களை இங்க யாருமே கொஸ்டின் கேட்க போறதில்லை, யாருமே உங்களை திட்ட போறதில்லை. ஸோ வாட்ஸ் ஆக்சுவலி என்ன உங்களுக்கு மைண்ட்ல தோணுது சொல்லுங்க. Anyone? யாராவது சொல்லலாம்ப்பா. ஐம் ஸ்டில் வெயிட்டிங். ஜெயகிருஷ்ணா சொல்லலாம், கிருத்திக், யாருனாலும் சொல்லலாம். நீங்க என்ன உங்களுக்கு தோணுதோ அது சொல்லுங்க. ரைட்? ஓகே, Jaykrishna something he text actually. So when a DC voltage is applied to the primary winding of a transformer due to low resistance, the winding acts as a short circuit across the terminals of the DC source that lead to a low heavy flow of current through winding, resulting overheating of the winding. Exactly 100% correct answer. So thank you Jaykrishna, right? So நீங்க கூகுள் பார்த்து எடுத்தாலும் சரி, இல்லை நீங்க ஓனா டைப் பண்ணினாலும் I'm very double happy about that, right? It's not 100%, 1000% correct answer, right? So it's a good answer, right? So we'll see how it going to happen. Simply this is answer, right? Thank you Jaykrishna. And right, so whenever I'm just going to apply DC power to my any winding, right? இல்லைன்னா பஸ்ட் ஆகும், இல்லைன்னா பர்ன் ஆகும், இல்லைன்னா sometimes it going to be much heat, blast out, right? So and temperature changes agala, and heating adhigam agala, we are just going with the AC and then we are just coming to DC, right? We'll go like this, right? So why not AC power supply kudukrappa blast agala, burn agala, but while applying a DC power, it's good to burst agala, blast. AC la therindhuchna DC easy, right? For that purpose I'm just going to go with that simple example. This answer already you people already well known. I'm just going to recall it, that's all, right? So இந்த answer உங்களுக்கு already தெரியும் அப்படிங்கிறது எனக்கு தெரியும். எப்படின்னா நான் தான் டீச் பண்ணேன். That's why I'm just giving a confident answer, right? So you already know the answers. That's why I'm just giving a confident okay? So right, so one more my flux lines, right? So first thing is now voltage. First thing, voltage, my input voltage, if it is AC I'm speaking. If I'm just connecting AC power source, this will happen. Input voltage will be like this. Due to this closed circuit, the current will start to flow, and due to current flow in this coil, there is a flux line is also going to be built it up. These things already we are well known, right? I already told it, so you know the answers, but I'm just going to recall it, right? That's all. So I'm just going to apply single phase AC voltage over here. What is going to happen? The voltage will be like this. Applied voltage, definitely in the closed path, the current is also going to flow based upon Ohm's law, right? So V is now getting linearly increasing, I also getting increasing, decreasing. This will follow the same path, right? Up current is now flowing in this conductor coil, right? So definitely the flux lines is also going to be built it up. The flux lines of structures because of the due to nature of alternating nature of current, definitely flux is also alternating nature, plus minus, right? So the flux line itself, it has a change in with respect to time, because flux paranga inga 0, inga maximum flux, for example 100 flux, again 100 வந்து 0 ஆகுது, 0 மறுபடி minus 100 மறுபடி 0. ஸோ அப்போ என்ன ஆகுது ஃப்ளக்ஸ் லைன்ஸ் 0 to 100. ஸோ 0 1 2 3 4 5 100 100லேருந்து 99 99 0 minus 1 minus 2 minus 2 so it's minus 100 minus 2 minus 0 and it's now continuously changing. So now dphi by dt is changing here. So dphi by dt is changing, right? So this is also copper conductor. Definitely it will induce one more EMF across this coil. This is called my E1, that's called self-induced EMF. Already we have discussed this one. Self-induced EMF, induced EMF is now going to build it upon my this coil. This self-induced EMF is called one more voltage, that's called E1. In the E1 inducer voltage, right, is now opposing my input voltage. This is what called my Lenz law, Lorentz force, Lenz law, right? So Lenz law indicates that, so எவ்வளவு voltage build ஆகும் E1, that's called E1, எவ்வளவு build ஆகுங்கிறது. So எவ்வளவு number of turns இருக்கு, flux line is going to be changing. So the minus எதை indicate பண்ணுதுன்னா, it's now opposing the input voltage, right? So the minus indicates that induced EMF is going to be opposed my applied voltage. So அதனால என்ன ஆகாது, இங்க நான் 230 voltage கொடுத்தாலும் என்ன ஆகாது, இங்க input voltage போகுது, இங்க induced ஆகிற EMF is now going to oppose this one. அப்ப என்ன ஆகுது, இந்த total circuitல resistance it will be somewhat very high, but it will be that opposing force, now it's going to be converted into flux lines are converted. So nothing going to happen here, right? But if you're having, right, so if you're having DC power source instead of having a DC power source, what is going to happen? See, for example, DC source எப்படி இருக்கும், there is a continuous electrical power supply. It's going to be a continuous power source, right? I'm just going to write from somewhere here, right? If I'm having a DC source, what is going to happen? So அதுலயும் voltage பாத்தீங்கன்னா, the voltage will be like this, right? So input voltage will be, this is time axis. DC source என்ன இருக்கும், voltage இருக்கும், current இருக்கும். So the DC source, DC voltage will be constant voltage, right? For example, 100 voltage DC. The voltage will be, there is no alternating in nature. Definitely 100 voltage will be straight line. So for the purpose, induced current எப்படி இருக்கும், it will follow the same pattern of voltage. It will also 100 for 10 amps. For example, I'm just giving 10 amps. So current will, it will allow the same pattern which will follow the voltage, right? அப்ப induce or flux lines, induce or flux lines, so it will follow the same flux lines, 100 flux lines, for example. So flux lines also will be constant. It doesn't going to be changing because of DC in nature. அப்ப எனக்கு எங்க கிடைக்கும், இங்க வெறும் 100 voltage அப்படியே ஃபிக்ஸ் ஆகி நின்றுக்கும், பட் இட்ஸ் நாட் கோயிங் டு சேஞ்ச். எனக்கு சேஞ்ச், ஃப்ளக்ஸ் லைன் சேஞ்ச் ஆகுறதுனால எனக்கு ஃபேரடேஸ் இண்டக்ஷன்ல, ரைட், there is one more self induced EMF is going to build it up, and the build or voltage is now opposing my input voltage. இப்போ இந்த பக்கம் voltage வருது, applied voltage, அந்த voltageனால தான் current flow ஆகுது, current flow ஆகுறதுனால தான் இங்க flux produce ஆகுது, flux வந்து change in flux இருக்கு. So one more EMF is inducing, that's called self-induced EMF. And the input inducer voltage, input voltage oppose பண்ணும், நீ உள்ள voltage வராது அப்படின்னு oppose பண்ணும். Now உள்ள per voltage there is no opposition. This now energy is now converted into magnetism மாறும், secondary coil அப்படி டெலிவரி ஆகி அந்த பக்கம் இதே பிரின்சிபல் நடக்கும், அந்த பக்கம் அவுட்புட் போயிடும். But in DC, now there is a steady state flux lines only is going to be built up. There is no dphi by dt. Let's see, this is the answer, right? Here steady state current, steady state voltage, and steady state flux lines. The flux line is not anymore, is now changing. 100 flux lines, 100 flux lines abhi hold aniko, nothing is now going to happen, right? Appa there is no opposing force is going to be built up, right? See, inga pathina AC kuduthina self induced EMF create adu, and the opposing force is now creating, that opposing force is opposing. But my DC, there is no dphi by dt, there is no opposing force. apply பண்ற voltage na அப்படியே போகும் circuit குள்ள, right? apply பண்ற voltage, there is no opposing inside, எதுமே இல்ல, அப்ப என்ன ஆகும், there is no opposing force is over created over here. அப்ப apply பண்ற voltage அப்படியே circuit குள்ள போகும். Now see, this is now closed path, there is no electrical load over here, fully pure copper conductor. So copper conductor, pure copper conductor resistance very low, right? So copper conductor resistance very low. Flow of current என்ன இருக்கும், there is no load. அப்ப full current is now going to flow, but there is no opposing force. AC ல இருக்க மாதிரி இருந்துச்சுன்னா full current போறதுக்கு சான்ஸே இல்லை. பட் எங்க opposing force இல்ல, ஏன்னா DC current கான்ஸ்டன்டா இருக்கு, கான்ஸ்டன்ட் ஃப்ளக்ஸ் தான் இருக்கு, there is no opposing force. full current is now going to into this circuit. அப்ப என்ன ஆகும், we already know the analogy. So this is a copper conductor, width வந்து 1 சென்டிமீட்டர்னா, so இவ்வளவுதான் வாட்டர் ஃப்ளோ போகும் அந்த PVC பைப்ல. நீங்க வாட்டர் ஃப்ளோ இன்க்ரீஸ் பண்ண பைப் என்ன ஆயிடும், பைப் PVC pipe is now broken. The same way copper conductor இருக்குன்னா, current is now flowing in much very high, because of there is no opposing force. அப்ப என்ன ஆகும், the wind is no going to be broken. That's why the transformer is now going to be born, blast iron. That's called a huge current is now flowing. That's why Jacobson also texted it. So whenever there is no opposing force is created due to self EMF irukadu because of steady state current irukku, steady state flux da irukum. There is no self induced EMF and as opposing force. A huge amount of current is now flowing into the circuit. It leads to the transformer is going to be blast, right? So this is what answer. So நீங்க எங்க போனாலும் பேசலாம், this is going to happen, right? So this is the answer, right? So this is a very important question, right? So in electrical department, electrical electronics, they will ask this question, right? So definitely they will ask this question. So why the DC transformer is not available in the market? But there is an arrangement for a DC generator, HVDC, high voltage DC transmission is also there. But அங்க என்ன பண்ணுவாங்கன்னா DC voltage again AC மாத்துறாங்க, AC DC மாத்துறாங்க again உள்ள. So that's what one more big interesting topic அது உங்களுக்கு syllabus இல்ல. But anyway, so this is a question. So if you are just able to connect a DC source of power supply into any winding of transformer, so what would happen? So definitely the transformer is going to be born. So why? What is the reason? This is the reason, right? So you need to tell. So anyone just have a quick snap. We'll move into next topic. Anyone just make it fast. So any doubt இருக்குங்களா? ரொம்ப easy தான், right?
Yes, sir.
Yes. It's a famous question, right? So நான் இண்டஸ்ட்ரியில் ஒர்க் பண்றப்ப எங்கிட்ட இந்த கொஸ்டின் கேட்டாங்க, right? It will be famous question, evergreen, right? Question. Always they will ask what is going to happen whenever the DC source is given to my transformer, right? And today we are just going to moving into one more thing. So before into that, I'm just going to show you the syllabus, right? So we need to have syllabus, right? 1 second. I think our syllabus is now visible to you, right? Yes, can you just confirm me? Syllabus தெரியுதுங்களா?
Yes, sir.
Yes, we just started. Yes, sir, thank you. And we started with the DC machines and DC generator. We crossed and DC motor is crossed, and we came across the construction, principle, and operation of a DC motor generator, and types of DC motors, and the speed control. Speed control of Ward Leonardo பார்த்தோம், and classifications பார்த்தோம். And then we came into transformers, and transformer we have discussed, and classifications, core and cell type பார்த்தோம், 3-phase, single phase we have discussed, and step up, step down we have crossed, and today we have crossed auto transformers. So up to we have just crossed this much, right? This much we have crossed. It's a big ocean scene தான் சொல்லுவேன். It's a huge topic, right? And today we are just moving into next era, right? So this is called alternator and AC motors. இது ரெண்டு முடிஞ்சதுன்னா ஃபர்ஸ்ட் மாடல் முடிஞ்சது. It's very easy. Right? So என்னோட ட்ரிபிள்யூட டிபார்ட்மெண்ட் எடுத்துட்டீங்கன்னா this entire subject, right? So first module, right? So 2 subject படிப்பாங்க. Up to DC motor, DC generator and speed control, they will have 1 semester subject. ஒரு செமஸ்டர்ல ஒரு சப்ஜெக்டே படிக்கிறாங்க, DC machines up to speed control, right? So and second semesterல என்ன படிப்பாங்கன்னா, that's called fourth semesterல auto transformer, alternator, AC motor எல்லாமே ஒரு செமஸ்டர்ல ஒரு சப்ஜெக்டே படிக்கிறாங்க. பட் you people now நல்லா வாட்ச் பண்ணி பாருங்க, 2 சப்ஜெக்ட் ஒரு மாடியூலா படிச்சிட்டீங்க, ரைட்? ஸோ படிக்க போறீங்க, ரைட்? அண்ட் தென் இது ஒரு மாடியூல் 1 தான், அடுத்து மாடியூல் 2 அண்ட் மாடியூல் 3 இருக்கு. ஸோ மாடியூல் 2 கண்ட்ரோல் சிஸ்டம், மாடியூல் 3 ஃபாலோட் பை கண்ட்ரோல் சிஸ்டம். ஸோ இந்த 2 மாடியூல் 2, 3 இஸ் நவ் கண்ட்ரோல் சிஸ்டம் ஃபுல்லி. ஸோ இந்த கண்ட்ரோல் சிஸ்டம் ட்ரிபிள் பீப்புள் தனியாக ஒரு சப்ஜெக்ட் படிக்கிறாங்க ஃபோர்த் செமஸ்டர்ல. சி initially I told that when started this course, initially I told that so 3 subject is now grouped together here. So combined of 3 individual subject which we are just studying as a triple people, உங்களுக்கு ஒரே சப்ஜெக்ட்ல 3 சப்ஜெக்ட் கொடுத்துருக்காங்க. So that's why the content is very huge. You people are also happy, right? So 3 செமஸ்டர் இதை தான் படிச்சுட்டு இருக்கீங்களா அப்படிங்கிறத விட நீங்க ஒரே செமஸ்டர் 3 சப்ஜெக்ட் படிச்சிருவீங்க. You will have that feeling, right? So ஷார்ட் டைம்ல நிறைய லேர்ன் பண்ணிக்கிற மாதிரி இருக்கும், right? You can have feel that one, right? So and today we are just moving into alternator, right? So today topic is now alternator. I'm just going to moving with that. So I think my screen is visible, right? So I'm just going to switch to alternator. I think anyone just confirm me alternator தெரியுதா? So my board தெரியுதான்னு பாருங்க, alternator. So yes, ஸோ ஒரு நாள் ஒரு 1 ஹவர்ல முடிக்க முடியாது. ஸோ ஸ்டில் பார்த்தீங்கன்னா டைம் பார்த்தீங்கன்னா ஒரு 10 மினிட்ஸ் தான் இருக்கு. Right. Anyway, I'm just going to give you that introduction about alternators. And next class, I will going to in detail about discuss about alternator. So why the name has alternator? Right, we'll discuss. So already we have discussed a generator, right? So we'll study the generator. So already we have discussed and came across this concept generator, right? So நம்ம என்ன பார்த்தோம் ஜெனரேட்டர்ல டிசி ஜெனரேட்டர் பார்த்தோம், ரைட்? நான் ஏசி ஜெனரேட்டர் பார்க்கல, ரைட்? ஸோ வில் டிஸ்கஸ்ட் அபவுட் டிசி ஜெனரேட்டர். டிசி இஸ் நவ் பவர், எலக்ட்ரிக்கல் பவர். டிசி ஜெனரேட்டர் பார்த்தோம். ஸோ this is setup, right? So north pole and south pole, and this is my rotating part. இங்க தான் நான் ரொட்டேட் பண்ண போறேன், and I'm just getting output over here through slip ring, right? So on carbon brush we will getting a rectified DC voltage, right? So this is what a generator, right? So this is what a generator, right? See, alternator என்ன பண்ணணும்னா it's also going to generate something, right? So it's also going to be act as a generator, but it's going to generate only AC voltage. That's the answer. As a common name generator, it could able to generate DC as well as AC by removing this copper and slip ring arrangement. By changing this copper split ring arrangement, you could have DC instead of you will have AC power. So we have discussed initially, without that commutator you could only have that alternative power supply, that is called AC, right? So as a generator na pathina, generator will have capable to generate AC DC, but alternator only is able to generate AC source, only AC. This is a basic fundamental difference between our AC as well as fundamental difference between generator as well as alternator. So around நீங்க ஜெனரேட்டர்ல என்ன படிச்சீங்களோ, this is north pole, south pole, armature, everything is now coming into play this alternate also. That's why I just damn sure that it will be very easy for you people. So right, நல்லா வாட்ச் பண்ணே தெரியும். என்னுடைய கிளாஸ்ல பாத்தீங்கன்னா ஜெனரேட்டர், டிசி ஜெனரேட்டர் I have spent around 5 hours. ஸோ எதுக்கு சார் இங்க மற்ற டீச்சர்ஸ் எல்லாம் பாத்தீங்கன்னா ஒரு 1 ஹவர்லேயே டீச் பண்ணி முடிச்சிருப்பாங்க. யூ குட் ஹேவ் தட் கான்வர்சேஷன் வித் ஒரு ஏ செக்ஷன் அண்ட் சி செக்ஷன் ஸ்டூடெண்ட். ஸோ அவங்க டீச்சர்ஸ் எல்லாம் பாத்தீங்கன்னா ஐம் நாட் கோயிங் டு பிளேம் யூ, ரைட்? ஸோ இட்ஸ் மை வே ஆஃப் டீச்சிங், ரைட்? ஸோ ஜென்ரேட்டர் தேர் ஜஸ்ட் அபவுட் 2.5 hours தான் ஸ்பெண்ட் பண்ணாங்கன்னா, ஃபார் யூ பீப்புள் ஐ ஹவ் ஸ்பெண்ட் அபவுட் 5 hours. வை ஐம் ஸ்பெண்டிங் திஸ் மச் hours? Because இந்த ஒரு கான்செப்ட் யூ ஆர் ஜஸ்ட் ஸ்ட்ராங், ஃபண்டமெண்டலி வெரி ஸ்ட்ராங் இன் த சென்ஸ் என்டையர் first module is very easy. So everything wherever go, that concept is going to be applicable, right? So that's why I have spent it. So the same way in alternator, around 80% of component will be same as my DC generator. Already we have crossed. That's why I told that alternate very easy for my B section students, very easy, right? So because of everything is now applicable plus alternator also, right? So now if I have 10 minutes time the topic, but we will go with that in detail, right? So that's why we'll just plan for a next class, right? Tomorrow morning, right? So we'll go with it. But 10 minutes I could able to complete it. It's no issues because we already well known about the DC generator. The same concept, 80% will be applicable over here also. Nothing difficult in this, right? So anyway, but before into that, we need a fundamental difference between generator as well as alternator. So as a generator, without a commutator segment, we could able to generate AC. With commutator, we could able to generate DC, right? So through carbon brush arrangement. But in alternator, we only able to generate AC source. So நல்லா வாட்ச் பண்ண தெரியும். So DC ல there is no frequency. Frequency ஒரு கான்செப்டே இருக்காது. There is no cycle, right? So only direct current is now going. But in AC ல alternating nature, that's why the cycle is coming. That's called hertz. Right? Cycle ஓட units பாத்தீங்கன்னா, இந்த cycle ஓட units பாத்தீங்கன்னா hertz. That's why ஸோ கமனை மைண்டில் வச்சுக்கோங்க. ஸோ generator வந்துருச்சா? But this is called alternator in the sense because it's going to generate only AC source. AC இருக்கிற alter in the called alternative power. Alternative generated by execution part. Right, I'm going to switch to screen. Yes, right. So now what I'm just going to do, right? So alternate load 2 minutes நான் ரெஃபர்மெண்ட் இன்ட்ரோ மட்டும் கொடுத்துறேன். So the same north pole, south pole, it will be there. Right, so I'm just having a rotating part. Right, so I'm just having a rotating part. Right, so this is what my coil. Right. See, and right, I'm just going to give a power supply, DC power supply over here. I'm just going to give a DC power supply to here. Right, now I'm just going to rotate over here. This is my rotating part. This is called my rotor. This is called my stator. It's a simple concept. What would I say? We're going to discuss in deep, right? So here I'm going பண்ணிருப்போம். இங்க தான் input கொடுத்திருப்போம். Power supply is given through carbon brush arrangement to my rotating part, right? So I'm just going to give you this rotation, mechanical rotation over here. நான் இது rotate பண்ண போறேன். So அதுக்கு முன்னாடி என்ன நடக்கும் நல்லா வாட்ச் பண்ணி பாருங்க. So இதுல கண்டிப்பா DC current is now flowing. அப்ப 100% flux line is going to be, for example, 100 voltage I'm just giving, 100 flux line is going to be set here. This is what a DC we have discussed in earlier, right? 100 voltage giving 100 flux lines, but there is no change in flux lines. That's the constant flux lines is given, right? Constant flux lines is going to be built up. But நான் என்ன பண்றேன், I'm just going to rotate this rotating part manually. So நான் என்ன பண்ண போறேன், manually rotate பண்ண போறேன். So அப்ப என்னவாகும், இந்த 100 flux lines is now constantly rotating at a constant speed. அப்ப என்னவாகும், 100% in 100 flux lines is now continuously rotating. அப்ப என்ன ஆகும், திடீர்னு ஒரு செகண்ட் 100 flux lines இந்த காயில் இருக்கும், அப்புறம் 0 flux lines, 100 0, because of this is rotating. அப்ப என்ன ஆகும், இதுல இந்த காயில்ல d5 by dt is now changing. Got a meaning right now? So அப்ப இந்த காயில்ல இங்க இது ரொட்டேட் ஆகுறதுனால ஒரு செகண்ட்ல 100 flux lines, இந்த காயில் இப்படி போயிடுச்சு, அப்ப இங்க flux lines 0, அடுத்த செகண்ட்ல 100, but in opposite 100 again சுட்டிட்டு இருக்கும். அப்ப என்ன ஆகும், இங்க என்ன ஆகும், இந்த அவுட்புட் சைடுல there is a voltage is going to be built up in alternating nature, that is called my AC. This is what my alternator, right? So we'll discuss in detail by tomorrow classes in detail, right? So any doubt in this? இவ்வளவு alternator, very easy. So இவ்வளவு concept, right? So the 60 mark question, இவ்வளவு answer, but tomorrow also we're just going to deal in depth, right? So how the alternating voltage is going to build up. This is called my AC voltage. So this is exact setup is now running on my thermal power plant. So இது rotates manually rotate பண்றலையா, instead of rotating manually we are having a turbine. So we'll have turbine we are just going to hit a steam is now converted into rotational energy. Turbine is now attached with my mechanical rotor, and mechanical rotor is now attached with my rotor armature is now rotating. Now AC voltage is now generating, right? So this is what exact system is out now available in metal thermal plant, right? So I think 3 o'clock. we continue with our next class by morning, right? So thanks for listening. Thank you all once again. Any doubt in this? Right? I guess I'm just going to finish it up, right? Thank you for listening. So we'll see you by tomorrow class, right? Thank you all. Thank you, Pa.
Thank you, sir.
Thank you, Pa. Thank you. Thank
Thank
you.
you, sir.
Thank you.